A gravel plant crushes gravel into sand. The sand falls from a spout and forms a right circular cone whose radius is always twice its height. So radius is always twice its height. The radius of the base is increasing at a rate of 6 inches per minute. So that's dr over dt is equal to 6 inches per minute. For part A, we want to find the rate in which the area of the base is changing when the radius is 8 inches. So the area of the base, so we have a cone like this. The base is a circle, so the area of a circle is pi r squared. So the derivative of the area with respect to time is just dA over dt. And the derivative of pi r squared is just 2 pi r times dr over dt. The radius is 8, so we can substitute 8 in for r. dr dt was given to us as 6. And so we wanted to find dA over dt. So we just need to multiply these out. So 2 times 8 is 16, times 6 is 96, and that's going to be 96 pi. We're talking about area here, so area should be inches squared, and because it's the derivative, we're going to put that over minutes. So this is our answer to part A. Now part B, find the rate at which the volume of the sand cone is changing when its height is 5 feet. So now for part B, we want to find dV over dt when the height is 5 feet. So the formula for the volume of the cone is 1/3 pi r squared h. And so we want to solve for dV over dt. But before we do that, we want to represent this all in terms of r, because when I take the derivative, I'm going to get like dr over dt and dh over dt. But nowhere in this problem do I know what dh over dt is. So I'm just going to rewrite this in terms of r. We see here r is 2h, so that means h is r over 2. So plug that in for h. And so this is, let's see, 1/3 times a half is 1/6, and that's pi. R squared times r is r cubed. So now we found a formula for the volume in terms of r. So let's take the derivative now with respect to t. So bring down the exponent. 3 times a sixth is just a half, and then you just subtract 1 in the exponent, multiply that by dr over dt. Our goal is to solve for dV over dt, but notice that the height was given to us as 5, and so the height is half of the radius, so that means the radius has to be 5 over 2, or 2.5. So I can plug that in for r, and recall dr over dt was given to us initially as 6 inches per minute, so I can plug that in as well for dr over dt. Now all I need to do is square the 2.5, multiply by 6, 1/2, and pi. And when I do that, I get 18.75. Now for the units, volume is, we know, inches cubed. And because we're taking the derivative with respect to time, time is in minutes. So the derivative of the volume with respect to time is 18.75 inches cubed per minute.